So some of you probably are kind of still mulling things over. You might be looking at a particular trait but not sure if you want to do it, or you haven't found something yet. You can pick from any one of these. This doesn't have to be something where you're all doing something different. I just want it to be interesting to you. So these are ones that came up during this class period and in the other class periods: color blindness and cystic fibrosis, and the smell of your pee after you eat asparagus, and freckles and red hair and polydactyly. All those would be great. We had one student just now who is going to look at the spiral pattern on snails. There's a kind of snail that it can have a left hand or a right hand spiral, and apparently that is determined by one gene, and it has just a couple of alleles. So that's a super interesting thing to look at. Yeah?
Is the one where sometimes cilantro tastes like soap to people one?
I don't know. That's a great question. Yeah, so cilantro taste, I know some people really don't like it. I don't know if it's a single gene or not, but you could look that up. The next step, so most of you are ready for the next step. The next step is going to be using your trait to develop a pedigree chart. And so when you look at a pedigree chart, it shows a couple of things that we're interested in. First, it's going to show biological sex. Biological males are squares, biological females are circles. Second, it's going to show marriages or matings and kids. Marriages or matings are horizontal lines, kids are vertical lines. And then it shows which individuals have the trait phenotypically. Okay, so a dark color on a pedigree chart means that the individual has the trait that you're considering. That doesn't mean that the trait is dominant or recessive. We just know that what they look or act like. So if we were to look at that list that we just talked about, like if we were to talk about curly hair, if you have curly hair, if that's the trait that you're investigating, then these individuals that are dark would all have curly hair. If the trait that you're investigating is pattern baldness, then these individuals that are darkened would all have pattern baldness. If it's freckles, then these individuals would all have freckles. It doesn't mean that the trait is recessive. It doesn't mean that it's dominant. It just means they have it. Okay? So when you do this, you've got a few different options for how you build this pedigree chart. I'm going to recommend that if it's something that you're interested in because it is a family trait, if you're comfortable with this, then you should use your own family to the greatest degree possible. So one of the students just now was talking about freckles. They were saying, yeah, I mean, I'm the only one without freckles. So that means you know the other people in your family, you know whether they have the trait or not. You could make a pedigree chart for all of the people in your family that you know have the trait. The problem with that is that you may only have a few people that you are close enough to know the trait. Like if you have a big family and you know them all, you probably would know freckles, but like some of the other things you might not know, like sickle cell anemia, you may not know. Like maybe you have it, or maybe you know that your uncle has it, but you don't know everybody else, and so there's going to be a bunch of blanks there. So we'll explain how you can deal with that. If you can use your own family and you're comfortable doing that, that's a great option. If you either picked something that doesn't apply to you or your family, or you're not comfortable using your own family, then find a real one somewhere else if you can. So the snail one that the student was asking about with the spiral snail shells, undoubtedly somewhere that student can find a pedigree chart showing the spiral, like whether it's left or right hand spiral for snail shells. And so ideally you'd be able to find an actual pedigree chart for the trait that you're looking at. If you don't want to use your own family or you can't, Go find a real one for sickle cell anemia or a real one for polydactyly. And if you can't find anything real, then you can make one up. And whether you find one that's real, use one from your family, or you make one up, I need it to have enough individuals that we can actually like get into detail. So the first piece is there should be at least 4 generations, so that's 4 rows, and there should be at least 20 individuals, okay? And if you are using a real one, but you don't have enough information to get there, you can add some hypotheticals, and I'll show you what I mean by that in just a second, okay? And then you gotta make sure that there's at least 2 phenotypes. One of those phenotypes should be recessive. It doesn't have to be the trait that you're looking at, but there has to be a dominant and a recessive allele, so there has to be a dominant and recessive phenotype. And because what we're really gonna be doing is thinking about the carriers and trying to evaluate that. So let me give you an example of this real quick. So we'll look at, one last thing that I want you to think about is there should be equal numbers of both biological sexes, roughly, right? Like it's fine if it's like 9 biological males and 11 biological females, that's fine. This is gonna allow us to determine if your trait is sex-linked or not. If it's sex-linked, it should show up more often in males, okay? So here is an example pedigree chart, and I'm gonna use my own family, and I'm gonna use blue eyes as the trait that I'm looking at. Okay, so my trait is blue eyes, and here's what I know. My mom and dad, neither one of them has blue eyes. I have 2 brothers. Neither one of them has blue eyes, but I do. So this is me. My brother, one of my brothers, married a woman and they had 2 kids, both boys. My brother does not have blue eyes. His wife does not have blue eyes. But both of their kids have blue eyes. And I had kids with Mrs. Bregar, who some of you know. She has blue eyes, and we had 3 kids. 1 girl and 2 boys, all of whom have blue eyes. Okay? So this is my starting point. Now the problem with this is I only have 3 generations, and I don't have 20 individuals. This is as far as it goes. My nephews are young, they haven't had kids yet. My kids are young, they haven't had kids. What I'm gonna do to add on to this is do just some hypothetical. I'm gonna say, okay, well, this could happen. It could be that one of my nephews marries someone who has brown eyes, and they have 2 kids, and they're both girls, and one of those girls has blue eyes. And maybe my daughter marries somebody who has brown eyes, and they have a daughter who has brown eyes. And maybe one of my sons marries a woman with blue eyes, and they have 2 daughters, both of whom have blue eyes. So this is all like theoretical, but it's possible. So I've taken this real pedigree chart and I've added some hypothetical stuff to it so that there's enough, we need to have enough individuals, and we need to have enough generations to work with, because ultimately what we're going to be doing is trying to piece together some of the genetics of this. We're going to be looking to see what alleles some of these individuals have, okay? So this is your next step. I want you to you can just write it in your notebook. This is not something you're going to turn in today. It's going to be part of the evidence that you provide to me, but it's not necessarily going to get turned in today. And what I want you to do is have the pedigree chart, 4 generations, 20 individuals, equal mix of biological males and females. Show your trait by coloring individuals dark who have the trait, and that's as far as we're going to go for right now. There's one more step that we're going to get to today. So this is maybe like a 10-minute exercise. If you look something up online, you just copy it from online. If you make something up, you have a little bit more thinking to do, because what you might find is you can't just color them randomly. You might find that if you just do random coloring, you might accidentally put together something that's not possible. And that's okay, because we'll tease it out later, but you're gonna have a little bit more of a complicated job. That's why it's better to use a real pedigree chart if you can, whether it's your own personal family or whether it's something that you find online that's real, okay? I'm gonna shut the video down, and then if you have any questions, you can ask, and if you don't, you have about 10 minutes to
I
do
have
this.
2 questions. I have one thing for you.